You are walking down a freshly paved street when you suddenly feel it. A deep pulse rising through the ground. Not loud enough to hurt your ears, but strong enough to travel through your shoes and straight into your chest. Then you see it. A massive road roller slowly moving forward, its giant steel drum pressing against the asphalt like a machine built to flatten anything in its path. Most people see that machine and immediately assume they know how it works. It is heavy. That must be the secret. After all, when something weighs several tons, surely the road becomes smooth simply because the machine crushes everything underneath it. But that explanation is completely wrong. In fact, if weight alone were enough, modern roads would not last nearly as long as they do. Some of the smoothest roads on Earth owe their strength to something happening deep below the surface. Something hidden inside that giant steel drum. And once you understand what it is, you will never look at a road roller the same way again. Before we continue, make sure to subscribe to the channel for more videos uncovering the hidden engineering behind the objects and machines we see every day. Because the truth behind road rollers is far more interesting than simple weight. The real secret involves invisible air pockets, a spinning piece of steel that is deliberately built off balance, and a design powerful enough to shake thousands of tons of material into place without destroying the machine itself. But if the roller is not simply crushing the road with its weight, then what exactly is it doing? Why does the ground vibrate so violently when it passes? And how can a machine shake the earth thousands of times every minute without shaking itself apart? To answer that, we first need to understand what road builders are actually trying to accomplish when they compact a road. To understand how a road roller really works, we first need to understand what road construction is actually trying to achieve. When workers bring soil, gravel, crushed stone, or asphalt to a construction site, those materials are not solid blocks. They are collections of countless particles stacked together. And between every particle are tiny gaps filled with air. Think about pouring rice into a glass jar. At first, the grains pile up loosely, leaving empty spaces everywhere. Then you tap the jar a few times against a table. Suddenly, the rice settles lower even though you did not add or remove anything. The grains simply moved closer together. Road construction works the same way. Those hidden gaps may look insignificant, but they are the reason roads eventually crack, sink, and develop bumps. Every vehicle that passes over the surface transfers force into those layers below. If too many voids remain trapped underground, the material shifts slightly every time a load passes. Over months and years, those tiny movements become visible damage. This process is called settlement. Engineers know that a road is only as strong as the foundation underneath it. That means the goal is not to flatten material. The goal is to eliminate as many internal voids as possible and force particles into a tightly packed structure. And this is where most people misunderstand the road roller. It seems logical that extreme weight would solve the problem. Simply press harder and everything should compact. But loose material does not behave that way. When a very heavy object rolls over gravel or soil, many particles simply move sideways. Some shift out of the way, others spring back after the pressure passes. The material changes shape temporarily, but much of the empty space remains trapped inside. The roller needs something more effective. It needs movement. It needs repeated force delivered faster than the material can recover. That is why vibration became the secret weapon of modern compaction. The giant steel drum at the front of the machine hides a surprisingly clever mechanism. Deep inside sits a rotating shaft connected to a hydraulic system. Attached to that shaft is a heavy steel weight positioned deliberately off-center. That detail changes everything. As the shaft spins, the uneven weight creates a powerful imbalance. Instead of rotating smoothly, it continuously generates force in different directions. Thousands of times every minute, that force travels through the drum and into the ground. The material beneath the roller is no longer being pressed. It is being shaken. Tiny particles bounce, settle, and rearrange themselves over and over again. Air pockets collapse. Gaps disappear. The particles lock together into a much denser structure. What looks like a slow-moving machine is actually delivering thousands of impacts every minute. And that single off-center weight is responsible for most of the work. The massive steel drum is not the hero of the story. The imbalance hidden inside it is. Once you understand what happens inside the drum, another question immediately appears. How does the machine survive? A modern vibratory roller can generate enormous force. The drum constantly transfers energy into the ground while moving forward across the job site. If all that vibration traveled through the entire machine, it would destroy itself surprisingly quickly. Bolts would loosen, metal joints would fatigue, welds could crack. Even the operator would struggle to remain inside the cab. The solution comes from something much simpler than most people expect: rubber. Between the vibrating drum and the rest of the machine sit specially designed isolation mounts. These thick rubber components absorb much of the vibration before it reaches the frame. The drum continues shaking aggressively while the rest of the roller remains relatively stable. It is the same basic idea used in many machines today. Control where the energy goes and prevent it from spreading where it is not needed. Modern rollers also give operators control over how that vibration behaves. Different construction stages require different levels of compaction. Early passes often need deeper force capable of reaching lower layers. Later passes focus on finishing the surface without damaging what has already been compacted. By adjusting vibration settings, operators can change how aggressively the machine works. This flexibility is one reason modern rollers are dramatically more efficient than older designs. Before vibration technology became common, road rollers relied almost entirely on weight. Early steam-powered rollers appeared during the 19th century and often required many passes to achieve results that modern machines accomplish much faster. The real breakthrough arrived when engineers realized that vibration could accomplish what weight alone never could. Interestingly, the idea did not originate in road construction. Early vibrating systems were used to remove trapped air from freshly poured concrete. Engineers noticed that vibration helped materials settle more effectively. Eventually, someone asked an important question: what if the same principle could be applied to roads? The answer transformed construction forever. Today, every smooth highway, parking lot, airport runway, and industrial yard depends on some version of that idea. And whether you realize it or not, you experience the results every single day. That perfectly smooth section of road that feels effortless to drive across, the parking lot without bumps or dips, the highway lane that remains stable year after year. Much of that quality was determined long before the surface layer was finished. It was determined underground, long before the asphalt arrived, long before the paint lines appeared, long before anyone drove across it for the first time. Before we finish, make sure to subscribe to the channel if you enjoy discovering the hidden engineering behind everyday objects. Because once you understand how something works, you rarely see it the same way again. The next time you see a road roller moving slowly across a construction site, remember what is really happening. The machine is not simply crushing the ground with enormous weight. It is carefully reorganizing millions of particles beneath the surface. It is removing hidden air pockets. It is creating a foundation strong enough to support years of traffic, weather, and constant stress. And the most surprising part is that the real secret is not the massive steel drum everyone notices. It is the deliberately unbalanced weight hidden inside, a small engineering decision that completely changed how roads are built around the world. And the results are everywhere. Every smooth road, every stable highway, every parking lot that still feels solid years after construction. They all trace back to the same principle: vibration. So here's a question. What surprised you the most? The fact that weight is not doing most of the work, the hidden off-center weight inside the drum, or the fact that modern roads depend so heavily on vibration rather than pressure? Let us know in the comments below. We read every single one. And if there is another machine, object, or piece of engineering you pass every day but have never fully understood, leave it in the comments as well. Your suggestions help inspire future videos and might become the next topic we explore. Thank you for watching, and we will see you in the next one. If there is another topic you want us to cover, comment below and let us know. Your comments are a huge motivation for us and help shape future videos.